new river lock of Seville. Seville, situated at 89 kilometers from the ocean and almost at sea level, has always been linked to the Guadalquivir River in the same way as its future will be. Its port, the only interior one in Spain and the third largest, is connected to the sea by an internationally important navigable route of 80 kilometers. At the height of Seville, the river has an average running tide of 2 meters, which makes it necessary to have an infrastructure allowing for the rise and fall of the level in order to enter or leave the port, whose water film is at a fixed level to facilitate the operations of the stowing and unstowing of ships. Lately, the port had important limitations which were threatening a large part of its activity and hindered its greater development, such as the little river depth or the working width of the lock, clearly insufficient for the present-day fleet. The progressive increase in maritime traffic has made it necessary to build a new lock to replace the old one, which dates from 1949, more than 60 years old, besides enlarging and improving the navigation canal, along with a remodeling of the port. The Seville Port Authority, belonging to the state ports, selected FCC Construction for the building of the new lock in joint venture, starting work in July 2005 and finishing in autumn 2010. The new lock is located at some 8 kilometers from the city, 1,800 meters downriver from the present one. It has an estimated working life of 50 years. The workable length of the new lock will allow the passage of Panamax ships, that is to say, those which can pass through the Panama Canal, which opens the doors to a considerable increase in short-distance maritime transport, which could reach 12 million tons of merchandise in the near future, against 5 million at present. The lock is an area delimited by floodgates, which allows the vessels to clear the different levels between the river and the port. The operation is simple and similar to a lift. The boat is placed between the floodgates, the water level is modified, the boat rises or falls, and finally, with the opening of the floodgate, the boat leaves with the new level. The average height of clearance is 1.5 meters. It's estimated that the filling or emptying of the pool can be done in 5 minutes, so that the total operation for a ship to pass through can be carried out in half an hour. But the Seville lock has another function, which is to avoid the city flooding when the river overflows. Seville is protected by a defense wall which surrounds it, and the lock forms a part with its outer floodgate. The wall reaches the maximum flood level for a return period of 500 years. In the case of flooding, the outer floodgate of the lock closes, thus protecting the city. The previous lock had 24.4 meters of working width and 200 meters in length, which enable the passage of boats of up to 5,000 TPM, while the new one has 35 meters of working width and 293 meters in length, allowing the entrance of ships of up to 20,000 TPM. The dimensions of the new lock are 434 meters in length and 40 meters in width, and it possesses 3 different sections. Metallic bascule bridges at each end of the structure. 2 have been made available for road and 1 for rail. The length of the decks is 42 meters and its thickness 3 meters, making the width 12 meters for the road and 6 meters for the railway. The piers are 25 meters high. They are operated by means of hydraulic jacks situated at the base of the piers, helped by some heavy counterweights placed in the overhead frameworks, and connecting these to the decks by tie bars halfway along their length. In the anchorage points of the piers, 3-meter thick buttresses have been placed. Metal floodgates operating horizontally and perpendicular to the axis of the lock, as well as living quarters or garages. Altogether, there are 4, 2 on each side. Normally, they operate with a single floodgate each side, but they are duplicated to minimize problems in case of breakdown. Their principal dimensions are 42 by 20.3 by 6 meters for those on the riverside and 42 by 17.3 by 5 meters for those on the port side. The garages can be converted into a dry dock to allow for maintenance and reparation by means of placing a bulkhead outside, so that the floodgates are, once the water is bailed out, hanging from the maintenance carts and with easy access to all its elements. The floodgates slide by means of two small carts of the same width, one lower and one upper. These carts, with four wheels of 1.2 meters of diameter each, move on rails, the lower one attached to the concrete floor of the lock and the upper on a bracket which juts out from the gable of the garage. Both small carts can be taken out. Some cables pull the floodgates from the upper cart, whose drums and motors are housed in a machinery building situated behind the garage, linked to it by galleries where these cables pass. The floodgates possess various installations, compressed air, sludge agitators, level probes, which enable them to work properly. The floating tanks stand out among these installations, whereby the reaction of the floodgates on the rails can be controlled, obtaining a balance between their own durability and the safety of the operation. If the whole weight of the floodgate leant on the rails, they would have a very short life, while if the floodgate didn't support anything, that is to say floated on the rails, any blow, wind or wave would take it out of its working place. In the extremes and inside the concrete footings, there are galleries which allow for the movement of people, services, installations, etc., from one side of the lock to the other. The floodgates have been designed to be feasible in their crest. This means that in the case of an emergency, these can be used as well as the bridges, with vehicles such as a maintenance van or an ambulance. Central pool, where the rise or fall of the vessels is produced, having as its principal characteristics the perforated concrete floor of 0.5 meter thick formed by PVC tubes 20 centimeters in diameter, and the diffuser zones where water enters and exits designed in such a way that they minimize the turbulence produced to the boats, reducing the lockage time as much as possible. The aqueducts which form the filling and emptying system are situated around the floodgate housing, having a box section of 5 by 5 meters, which branches in two ducts of 5 by 3 meters. Its exterior entrance is situated 3 meters above the concrete floor, thereby limiting the entrance of sludge into the system. The structure works like independent walls of a variable thickness supported on concrete footings, with a drained concrete floor between them, to avoid uplift pressures, except in the area of garages where, to avoid differential settlements which could cause problems in the rolling of the floodgates, continuous bases of 124 meters in length, 61.5 meters in width and 5 meters thickness were chosen, thus creating a practically immovable mass. The walls are up to 20 meters high and 4 meters thick, although in the garages there are huge areas of concrete of more than 10 meters thick. The foundations have a 3 meter thick in the central and bridge areas and 5 meters in those of the garage. The work is completed with two supporting docks made up of sheet piles and two dolphins, as well as the control building, offices, machinery and general services, occupying an area of 2,182 square meters of a total urbanized area of 69,000 square meters. The control building of 3 floors is constituted as an independent element in a central position. It has a perfect view of the whole lock, as well as the access boat canal of up to 4 nautical miles. From it, the priorities of passage will be established. The constructive process of the work involved the prior conjunction and planning of a long list of complicated tasks and the running of high-quality production teams not normally employed in other types of work. The different phases were grouped in carrying out the building enclosure, building the structure of reinforced concrete and sheet pile docks, flooding the area, making and placing floodgates and bascule bridges, preparing works, dredging, making closing dikes and roads over the canal for port access, opening of the basin and setting in operation. The previous roles in carrying out the work include a geotechnical inspection, a project of archaeological intervention, a report on the protected flora and fauna, and the strict observance of environmental surveillance. To build the lock, it was necessary to create a watertight enclosure, as the excavation would be 25 meters below the phreatic level. This enclosure would have various access ramps for the machinery and materials. The work began simultaneously with a superficial excavation and the construction of a locking wall made up of bentonite cement 1 meter thick, which would be fixed in the watertight layers of the bottom at 1 meter minimum, which gives an average depth of some 25 meters. 300,000 cubic meters were dredged, and later on, once the enclosure was closed and the water from the inside eliminated, excavation with mechanical land equipment of great yield continued full out, working extra shifts until the final level was obtained. After reaching the planned level for the foundation, its construction began, for which 2 concrete mixing plants were previously made available at the site, with a nominal capacity of 99 cubic meters per hour each one. 6 tower cranes of 60 meters of boom and maximum load on tip of 4.2 tons, and a stocking of concrete reinforcing steel park equipped with another tower crane and a storage capacity of 20,000 tons. 300,000 cubic meters of concrete of different resistances were used. 20,000 tons of corrugated steel framework, 100,000 square meters of formwork, of which 70% was climbing, and 1.2 million cubic meters of earth-fill backing of the structure, which was carried out at the same time as its execution so as not to delay the work overall. To guarantee the durability of the concrete with great outputs in the summer, its maximum temperature during the setting was tested, controlling it during the operation by means of thermocouples located in the mass. The maximum ones reached were 30 degrees in placing and 70 degrees during the setting. To obtain that working temperature, placing so low in Seville, the aggregates were shaded and watered. A cooling machine with added ice for the mixing water was used, and a sufficient storage capacity of cement was maintained to guarantee its cooling down after leaving the plant and before it's being added to the concrete. The transition between the slopes of the access canal river banks and the vertical surfaces of the lock was carried out by means of sheet pile docks of 225 meters in length on the north edges and of 90 meters on the south edges, with depths of up to 28.5 meters in some cases, anchoring them to other sheet pile walls situated in the rear part to guarantee their stability. The anchoring of the circular areas, which didn't admit that solution because it produced an excessive concentration of tensions due to the less length of the rear wall, was carried out by a horizontal slab, which would work by friction instead of mobilization of the passive earth pressure. Once the structure of the lock was completed and its mechanical elements on land, as well as the sheet piles of the enclosure, the flooding of the pool began, which took a total of 11 days. When the water levels in the river and the pool were the same, the last part of the blockage which impeded the entrance of the water in the enclosure was dredged. Meanwhile, in the Seville dockyards, the construction of the floodgates was carried out. They consist in great plate boxes braced with metal sections. Due to its enormous weight, 800 tons each one, they were moved from the dockyard to the site along the access canal by means of 2 tugs, one in prow and one in stern, passing through the previous lock.